Welcome to the Engineering Show, where we aim to share our passion and excitement for engineering with you. My name is Gina, and today I'm joined as always by my lovely co-host and fellow RMIT mechanical engineering student, Gabriel, who will be interviewing our very special guest today. Before we go on, I'd just like to give a quick shout out to Dr. Elizabeth Kyriakou, Senior Lecturer here at RMIT in Mechanical and Automotive Engineering. Dr. Kyriakou saw a need for us engineering students to have a voice, and without her support, we would not be here talking to you today. So a big thank you, Elizabeth, not only for arranging today's interview, but for making this show possible. Now, one of the aims of this show is to explore what it means to be an engineering student, both today and moving into the future. And who better to help us do that than the Executive Dean of Engineering here at RMIT. I'm very honoured to welcome our very special guest, Distinguished Professor Adrain Mouritz. Adrian, welcome to the show, and thank you so much for taking the time to speak with us.
Thanks, Gina. It's great to be with you all today.
Yeah, we're very excited to interview you. So I guess we'll just kick it off now. So as the Executive Dean of Engineering, could you give us an overview of your role at RMIT, and what do you find most rewarding about heading the engineering department?
So the Executive Dean role that I have is effectively being responsible for leading all of the engineering research and teaching and the academic staff and the students at RMIT. And that's quite a large school. We're actually the largest school at RMIT, and RMIT is a pretty large university. And I'm very proud of our school. We've got fantastic students and we've got brilliant staff. And hopefully people appreciate that. So in my role, as I mentioned, it's predominantly to ensure that this school moves forward in terms of delivering really high quality engineering education to our students. And that includes our undergraduate students, our postgraduate master's students, and also our doctoral students, or what we call HDR, high degrees by research students, of which by head count we've got over 7,000 students. Oh, wow. And also our academic staff, and we've got about over 300 staff teaching a wide range of engineering. So I've got overall responsibility for the academic staff, but also the professional staff that work behind the scenes supporting the academic staff and the students in their teaching and research activities. And I'm also got a role to ensure that the school is fully engaged with industry, and we work with a large number of industries across the engineering sector, both here within Australia, but also globally, overseas, and also professional societies like Engineers Australia. So it's a very diverse role, but I love doing it, and I've got a fantastic team who support me in that role. And every day I jump out of bed really excited about what the day is going to hold in the Executive Dean role.
Yeah, it sounds like a very, very heavily responsible sort of job, that's for sure. I'm not sure if I'd be capable of doing something like that. So maybe let's go back in time a little bit. What made you choose engineering in the first place?
Well, I'm probably not that dissimilar to, I think, a lot of students. I started university when I was 17. I finished year 12, and I wasn't too sure what I wanted to do. All I really knew was that I wanted to do something in the field of science and technology. I really didn't know what engineering was. I didn't know any engineers. My parents are not engineers. My parents, both my mum and dad, are pharmacists. So I had a little bit of a science background from that, but I quite literally didn't know any engineers. I ended up doing my undergraduate degree at RMIT back in the 1980s. And RMIT then was a pretty different place to what it is now. It's a lot smaller and a lot more focused. And I actually studied metallurgy, which we no longer offer here at RMIT. And I don't know why I picked it. I just picked it on a bit of a random choice. And I didn't really know much about it. Again, not only did I not know any engineers, I didn't know any metallurgists. And anyway, I started the program, and it took me actually a few years to really get into it. I mean, I passed all my courses, and I attended classes and did all the right sort of things, but I never really had a passion for it until my final year.
Okay, wow.
I did my capstone project, and it all started to make sense to me, what I'd learnt over the previous years in the metallurgy degree. And it stopped being something that I was doing to something that I actually loved doing. And that really set the course. I didn't know it at the time, but it really set the course for the rest of my career. That experience that I went through while I was an undergraduate student. So I do very much emphasise with students who just don't really know what they want to do. And my view of that is it doesn't really matter too much. Just do your best and stay the course. And eventually over time, I think you'll find something that you really want to become passionate about and want to become the vocation. Very few people, I think, enter an engineering degree or any other university degree and know that is absolutely the only thing I want to do. And if for those few students, great, good on you. I think you're a little bit lucky. I certainly wasn't that lucky, but I turned out being very lucky by the end of it because, as I said, I ended up studying a field that I knew nothing about, had no real appreciation of when I started, but by the end of it, I really, really was glad I made that choice.
Yeah, wow, that's a fantastic sort of insight. Because I do see a lot of students who are going through a similar thing, like you said, and it's nice to know that you know, they're not alone, and people have gone through you know, those experiences and then come out in a very, very good position, and yeah, they had a very fantastic career. So that kind of brings me to my next question. What is the most memorable project that you've worked on?
Really good question, and I struggle to answer it because I've worked on so many great projects over my career. After I finished my undergraduate and master's degree at RMIT, I went and studied at the UK and got my doctorate at Cambridge. And then I actually started my career, and I think I was about 26 when I first started my first job.
Okay.
And then I've done a number of different jobs before I ended up joining RMIT again, came back after a very long period away as an academic staff member back in around about 2000. So while I've been here for 21 years. And over that long period of my career, I've worked on a lot of different types of projects, and they're all very, I've enjoyed a heck of a lot of them for different reasons. But if I were to pick one, which was actually a very long project, we didn't realise it at the time, but when we started on this project, and the project was something that we were doing with the Defence Department, so the Australian Navy specifically. And the Navy was concerned about fires on ships because there'd been fires on ships before, people had been injured, and unfortunately in a couple of incidents, some of the sailors were killed. And so the Australian Navy was obviously very concerned about fire safety on their ships. And they got us to start to explore one aspect of it, which was really both a modelling. So we did a lot of computer modelling, and we also did a lot of experimental testing. And I thought the project would end up going for maybe a year or so. It ended up going for 10 years.
Wow.
And it just grew and grew and grew, whereby by the end of it, I ended up leading an international team that involved researchers from Australia. We had a big group at RMIT working on it. I was also leading a group at the Defence Science and Technology Organisation, which was doing the science and technology for our Navy. I was also leading a group at Newcastle University in the UK, at Virginia Tech in the USA, and also a laboratory in Switzerland. And so I had this fantastic position of being able to lead a very, very talented group of researchers who all had the passion that I had to try to solve this problem to make Navy ships safer. And the work actually ended up being supported very, very strongly by the US Navy. And I think in that 10-year period, I took 20 trips, or maybe even 25 trips to Washington, DC, to talk to the US Navy about that research. And that was really good for a number of different aspects. Firstly, we were discovering things that no one ever knew before. And so that whole doing that work whereby you've discovered something that no one else knew about up until you've found it out is a pretty amazing experience in terms of what we call discovery type research. But it didn't finish there. We actually then had to translate that research into something that was useful and practical for the navies, and we did that. And that was a pretty neat project to work on. And I worked on a whole lot of other different projects, but that to me was a highlight just for a whole lot of different reasons.
Yeah, it sounds amazing. It's such a very epic undertaking, and you know that it can come around and go full circle, and you can look back and see it's completed. It must be very satisfying. So I might hand off the next question to Gina, so I'll let her take it away.
Well, I was kind of curious because you did your undergraduate studies at RMIT, and I was curious what you think are some of the biggest differences or developments since that time for engineering students within RMIT or in general.
Yeah, great question. And I actually spend a lot of time studying this in my role. How is engineering education changing? And also, what sort of skills and other attributes are employers looking for the engineers of tomorrow, which of course are our students now. And in my career in engineering, some aspects haven't changed a lot, but other aspects of engineering have changed an awful lot. What really hasn't changed is we still really need a good understanding of the fundamentals of our discipline field. So, for example, if you're doing mechanical engineering, just for one example, you still got to understand the basics of mechanical engineering. You've got to understand your statics, your dynamics, engines, all of those sorts of things that mechanical engineers study. What's changed a lot though? Well, there are a few things that changed a lot. What's changed a lot is, I think, engineers now need to be a lot more broader in their thinking than probably what they even were just 5 or 10 years ago. And what I mean by that is you still got to have that discipline expertise, but ideally an engineering graduate should know more about engineering than just their specific discipline field. And they should have a broader appreciation of some of the other allied fields of engineering and how they connect to their own discipline field, okay? So rather than just wearing one technical hat, I think we're seeing engineers now who need to move in wearing multiple hats while still having that core expertise. Another thing which is fundamentally important for all engineers, and this has always been around, but I think it's becoming more and more important, is what I call the professional skills of our engineering students. So there's the technical skills, there's the professional skills. And the professional skills are, to some extent, a lot less clearly defined than the technical skills, but still very important. And they're things like being able to communicate effectively to non-technical people, non-engineers. It's also about working effectively in teams. It's also about the whole lot of other activities that engineers need to do their work, but they're not reliant solely on just their technical expertise. Okay, so there's some of the major issues. Where engineering at the moment is in a really exciting period. You know, that's moving towards digital technologies. Okay, why a lot of the hardware that we're doing in engineering will always remain. We're getting smarter in the use of digital engineering, and that's things like augmented and virtual reality, the creation of digital twins rather than creating physical prototypes, Industry 4.0, where we've got a fully integrated system that includes both engineering hardware, software, the internet, big data, and even the economic aspects of the engineering systems process. That is really taking off now. And at RMIT, we're aligning our students' education so that they're equipped to enter the workforce with a better understanding of digital engineering than our graduates of the past. But that's really a very, very exciting thing, and it's an irreversible trend that the industry's started on, and the industry's finding their way with that, and we're making sure that our students are getting the right technical and digital engineering skills that they need so that they're job ready and they can go into the workforce and hopefully actually know a little bit more about digital technologies and some of the practicing engineers that are already in industry. So I think there's some of the major themes that are coming out in engineering: the technical knowledge you must have, the professional attributes you must have, but this emergence of digital technologies and everything that encapsulates are all very important for our field.
Yeah, thank you for that. I certainly noticed, I was studying part-time for a couple of years, so I've noticed some big changes in the course over the few years involving more digital job readiness, and it's great. It's very exciting. Thank you.
Yeah, and we'll be doing even more next year and the year beyond that.
Yeah. All right, back to Gabriel.
Yeah, so I guess we'd sort of be remiss if we didn't address the current situation, and you're talking more about, getting ready for the future, and I guess, moving on towards a more digital platform as far as engineering goes. And I guess I'm curious to see how, what your thoughts have been like working through the COVID-19 sort of pandemic, and how, and sort of anything that you've learned from that, and what you think would be, I guess, the positives that could come out of this for engineering as a discipline.
Yeah, great question. Without a doubt, I mean, I'm making a very obvious statement here. COVID has been incredibly disruptive to society, to the engineering sector, to the Australian and global economy. And it's also fundamentally changed, I think, the way that we are working, both as students, as academic staff, and also in industry. Where we actually land in the post-COVID period, I don't think anyone really knows, other than it will be different to the pre-COVID period. But maybe let me make some somewhat random comments, and I'm happy for you to follow up on any of those points as we go through them, and in no particular order of priority. I think just the way that we communicate will change to some extent. I think prior to the COVID outbreak, we were much more reliant on direct physical face-to-face in talking and communicating with people. It really has become a virtual environment where things like Zoom and Teams and that are working. And I think that we've found, and certainly my experience is, it works just as well. In some extent, it may even work better than some face-to-face meetings. And I think post-COVID, we'll probably have a blended approach in the way that we get together as working groups, whether that be students, whether that be staff, whether that be engineers into the workforce, whereby we'll continue to do face-to-face. That's always going to be important. But running in parallel with that, I think we'll have digital platforms that will communicate through either, one-on-one or in more Teams type environments. I think for industry, I mean, I talk a lot to industry, and they're like the rest of us. A lot of them are working from home. And I think the senior managers in industry have realised that people can work just as effectively from home, and in some cases maybe even more effectively than if they're actually in the workplace. And again, I think post-COVID we'll see in industry this blended working approach where some people will spend some time on site in the company, but where it's not essential, they might have more flexibility and be able to work from home. I think some of the other things that have come out of it is more from a university perspective, is the way that we educate our students. This year was incredibly disruptive because we had to basically switch all of the classes from face-to-face to fully online in week 2 of semester 1. And I thought that would be a monumental train wreck. And it actually worked out okay. If we look at, generally speaking, the student satisfaction in the quality of the teaching that we're delivering to them, and what they're calling their overall satisfaction in the program, that is exactly the same as it was with face-to-face. So I think what we'll find in universities is post-COVID, it will again be a bit of a blended approach where we must do our labs on campus. We need to do our tutes in groups face-to-face. The information that we can put online, we should be putting online. And again, having this blended learning approach where we're combining the best elements of online/digital learning with the more conventional face-to-face type education, particularly centred around tutorials and laboratories. I think that's probably what's going to, how the future will play out for us, at least over the next couple of years. Beyond that, my crystal ball's not so good, and I'm not too sure how we'll stick to a blended approach. But some real positives have come out of COVID, despite all the social and economic disruption. And some of the real positives, I think we can do things better than what we've done in the past because we've been forced to adapt and change due to the restrictions around social movement.
Yeah, that's fascinating. It's great to get your opinion on that because it is, yeah, it's a very interesting and you're saying, yes, disruptive time, but yeah, there is quite a lot of good that can come out of this, and engineers are nothing if not adaptable. So I'm sure we can always find some new and innovative ways to sort of deal with a situation like this.
The other thing, sorry, Gabrielle, for cutting. The other thing that occurred to me very early in COVID is we wouldn't be able to function as a society and work from home if it wasn't for engineering.
Yes.
Even fundamental things like having a computer at home, Wi-Fi, all of those sort of digital technologies that we need to do our work and do our learning wouldn't have occurred if it wasn't for us. And I think we should be proud. I mean, engineers are not great sellers to the public about the successes and the achievements that we deliver to society, but without a doubt, Australia would be in a really, really broken place if it wasn't for engineers giving society the tools it needs to adapt to COVID.
Yeah, that's very true. Yeah, it's great to get your insight on these things as we're all going through it together. I might actually wrap it up here. So what would you say to the students out there studying at the moment?
Oh, look, I do have a message for the students, but I think the thing that I'm very, very conscious of is all of our students, even though, as I mentioned earlier, we've got over 7,000 students, they're all individual. And it's hard to generalise because I know many of our students have done it really tough during the COVID period. It's very, very hard to make general statements because everyone's in their own unique position, and therefore it would be trite of me just to make some general statements, other than to say I would hope and think we're through the worst of this. I'm a great believer that society probably won't get back into its pre-COVID stage until the vaccine has been created and people have had an opportunity to be vaccinated. And I don't know when that will be. I'm following it with great interest. Personally, I'm very interested in the vaccine technologies that they're developing around the world. But all I can really say is stick with it. All of our students to some extent have been disrupted, some more so than others. I'm also very conscious of our first year students and their first year undergraduate students. Or they might be first year postgraduate students or research students where they joined RMIT, but they haven't yet had the campus experience. They haven't yet been, because of the lack of the campus experience, they really haven't had the opportunity to create the friends and do the sort of social things that we love to do as students, join social networks, join clubs and societies, sporting groups and all of those sort of things. All I can hope is that next year's a lot better and all the students can make the best of that opportunity to try to make up for what's been lost this year. in terms of that connection with campus and connection with the other students and connections with the academic staff.
Can I just say, we won't keep you any longer, but you know, thank you for acknowledging the difficulties that we have been experiencing, and it really does mean a lot to me, and I'm sure other students, to hear our executive dean making the time to speak with us and being so encouraging. That's I think the biggest message for me. It's been great. Thank you.
Oh, look, it's my absolute pleasure, and I wish all the students and other listeners into your program to hang on in there. If they're currently studying to be engineers or they're currently practicing engineers, you found the best vocation in the world.
Yeah.
Just stick with it. Engineering is fantastic, despite what other people say about us. Yeah. Thank you very much.
Thank you.
Great, thank you. Hope to speak to you again soon.
Yeah.
Cheers. Bye bye.